Hello everyone and welcome to today's webinar. I'm Philip Radukic, a product manager and senior consultant at CI Experts. Today we'll be continuing our short series that introduces you to the three basic modules of UPV Web Services. These modules will help you centralize your models, become independent from hardware or operating system requirements, and track issues, action points, and more. So the three modules of UPV Web Services are the UPV browser, which we had a look at 2 weeks ago, and browser-based viewing, which is today's topic. And in 2 weeks' time, we'll have a look at the system for workflows that most of you will know as a workflow system. So in today's session, we'll focus on the browser-based viewing and how it can simplify your daily work, streamline administration and IT, and reduce costs in your company. Please note that this session will be recorded and we'll send you the link to the recording via email. During the webinar, as always, feel free to use the GoToWebinar questions panel to state your questions, and I'll try to answer as many as possible after the session. If I'm unable to address your questions during the webinar, I'll respond to you via email. Now, let's take a look at today's agenda. So first of all, we'll have a general introduction to UPV Web Services with a small flashback to the previous webinar, then the detailed introduction to browser-based viewing, what it is about, and a live demo that will be covering overview of the user interface, working in the browser, loading versus preloading, settings, and advanced features. So when we're talking about UPV Web Services, what is this? The UPV Web Service is a comprehensive term encompassing all CI Expert services that rely on web browser applications, leveraging a stack of interconnected applications that eliminate the need for local installations. What does this mean? Well, you don't need to install any of the software locally. It runs completely independent in a browser. This approach allows for seamless accessibility and utilization of the services without the hassle of individual software installations. The UPV browser, as the first and basic module, is introducing the enhanced successor to our folder browser, with the difference that it's now equipped with advanced security and administrative features powered by an identity server, and this powerful tool functions as a distribution server, authentication and authorization server, and thus enabling seamless streaming or downloading for local UPV applications. At the same time, it's also the base, as you might have noticed, local UPV applications is also the base for the browser-based viewing, going one step further. So building upon the UPV browser and identity server, this latest iteration extends its capabilities to enable UPV usage on any device with a web browser, independent of the operating system, and eliminating the need for device setup installation. So to ensure smooth operation, the only thing you will need here is a really good performant machine as render server equipped with a high-end GPU to do the rendering that will be transferred to the client in the browser. And the workflow system or system for workflows excels in providing a centralized collaboration platform for design reviews with various features such as centralized commenting, centralized sketching, task assignments, and also enables efficient information exchange, facilitates discussions through discussion boards on different issues within a broad team, and also allowing communication on a project based on different tickets, and it's very flexible to use it. So this could be maintenance calls, this could be some just notes regarding your digital twin, but it could also be some design reviews or similar. So where is the UPV, or where are the UPV web services actually placed in our product pyramid? Well, first of all, we've got the adapters that culminate in the builder that creates models for the UPV application. The UPV application, again, can have different modules. I'm not going into the details here, that eventually end up with the model being viewable in the Universal Plan Viewer. And as a top of the pyramid here, the UPV web services are located. And you can also see in the pyramid the dependencies. The UPV browser is the base, browser-based viewing building on top of UPV browser, and the workflow system building on top of the other two. So, highlighted is today's topic, browser-based viewing. What are the challenges? So, working with inadequate hardware bears the risk of having weak performance and time loss due to weak hardware, not really workstation, but low-grade laptops. So not every department does have a high-end workstations like engineering departments. So if you want your model viewed and used, a digital twin used on a broad base in the company, hardware can actually prove to be one of the blockings, how to say, roadblocks. Then again, low network speeds slow down transfer rates. This means even if you host your model centrally but use local applications, the model data, model information needs to be transferred to these clients either by download or stream. And let's be honest, it can take ages for models to be opened from network. And I've also experienced in the past that at the same customer, just by being connected to two different switches in the background, sitting in the same office, just a few yards away, two people had really high differences in loading times just because of slow networks. Well, even loading models, if they reach a certain size, and no matter what software you work with, they can also take some valuable work time until they finish loading. And the downside is that employees, in many cases, can't do other things with the computer while it's loading. And last but not least, model updates take longer to reach the addressee due to the above mentioned reasons. So if I'm working with a locally cached encrypted or locally downloaded encrypted model, the first step we take here is notifying the user, hey, there's actually an updated model available. But still, there's the time that you need to actually download or cache these. So model updates are not instantly available for all users and need to be cached or downloaded first. What are the solutions? Well, first of all, the client hardware becomes irrelevant. In fact, high performance regardless of the hardware used. So it doesn't matter if you're using a thin client or a high-end workstation, you will always get top-notch performance here. Network speed has little impact on performance. Well, great performance throughout the whole network because we're just using a very narrow bandwidth to transfer information. In this case, it's the ready rendered graphical information to the client, and from the client to the server, only keyboard and the mouse inputs. That way, we streamline the amount of data exchanged, and network speeds in general do not have a major impact anymore. Models can be preloaded easily. Well, you can have the hugest models available in mere seconds. What this actually means practically, we'll come back to that during the live demo on the topic load versus preload. What's the difference and what's the impact? And last but not least, model updates are instantly available after upload to the render server and can be loaded almost instantly. This means even if you get a notification, hey, there's a new version of your model available, all you have to do is close the session, reopen it, and within seconds, you're just working with the latest and greatest model version. This way, you're saving on also some error costs that can surface by actually delaying loading a new model because it just takes time. And that way, it speeds up all processes connected to viewing and model availability and accessibility. So let's actually now have a look at the live demo. For this, I'll just log into our demo website. Of UPV WebServices. So a small flashback to our last webinar where I've been showing the UPV browser. So the UPV browser does not only allow you to open models locally or download. With browser-based viewing in place, this means a render server available. You can also have the options to open in browser, which is also activated by default if both options are available. So the UPV browser, you can have list view, tile view, dedicated tags for individual models. You can search by descriptions. You can view under the information tab or button. But with models coming with browser-based viewing, you also get some informational data here. Please remember this. We'll be coming back to this in a moment. So when I open our demo plant here, all I have to do is just click on Open in Browser, and you see almost instantly I actually have the model available and can move around the model and use UPV like it were installed completely locally on my machine. So no hassle with any type of installation, permission rights. And another big advantage is when rolling out updates, you don't need to update every single client machine. You just update the render server and all users will automatically be using the latest version. And even most important of all, everybody will be working with the same version. So this again saves time, effort, and thus money for the IT infrastructure and administration. So, but how does it work in a browser if I want to actually save away some files, like reports, or in this case, for example, UPVF files? So I could go ahead and say, okay, let me save away the points of interest, hit save, and I've already saved them once here. So let me just overwrite them. We get a save as dialog, very similar to the one in the local UPV installation. And the same way back, we can also just delete this and load a saved file, which was POI. And you see the points of interest have reappeared and were loaded into the model directly through the web browser. So the integration in the browser is seamless and identical to the already well-known UPV experience here. Another advantage, there's no need for the users to switch to different, approach to using the system. It will just stay the same, except will be more performant. What does more performant mean in this case? I can actually show you another example, but before we do that, let's actually concentrate on the topic, what does load mean or preload? Preload means that on the render server, you can, and let me actually go into the settings where we can see the render server here, public demo, where I can define a search path where it will be looking for models, and in return I get the list of found and available models in that search folder. I can set a certain number to preload. Preload means that usually when you open a model, you have to wait until it's finished loading. In this case, on the render server, the administrator can actually set a certain number of instances to be already loaded on the render server and put into idle mode. And as soon as a user actually requests that model, it will be instantly provided and streamed to that user. So in the meantime, this would leave us, for example, for our full demo plan with only one preloaded session. In this case, the UPV web services and render server keeps repeating the preload so that always two instances are preloaded at basically any given time. In order to not clog our server, we could, for example, set also a number of maximum streams valid for that model, so it's not preloading indefinitely, but only to a certain number of instances, after which a message will be shown that currently no seats are available. But this way, we're anticipating the usage of models and preparing the software and preparing the server to provide these models to clients as soon as they request them. What is the opposite of preloading? It's just loading. So I can take, this is also a small model here with 110.5 megs, but you see, while this one has a green dot, the other one has a gray one. What does this tell us? It tells us this one is preloaded and instantly available, while this one will be loading on demand. For example, because it's not requested that often, or because it's been an old version, and as soon as it takes longer, also the BrowserBasedViewing will inform you, please note that models not preloaded might take longer to load. Once it's loaded, it's the very same behavior like with the preloaded ones. So in this case, loading this model went relatively fast. So one of the reasons why I decided, well, I don't need to preload these. It looks a bit different when we're actually talking about huge models. The demo plant I just had opened is, well, a regular sized plant for demos, but we wanted to see what if we actually created 1,024 copies of this demo plant. How do we perform in that case? So what we did is not only just creating copies, but all of them have, every copy has its attributes and basically the full range of information. So it's not just a cloned copy that we're referencing somewhere. It's like a real plant here. Additionally, just to give you some impression of the sheer size of this plant, it's 2.4 by 2.7 kilometers, which is something between 1.5 and 1.7, I'd say 1.7 miles in size. And as you might have noticed, it was, like the smaller model, instantly available, even though loading would probably take longer here. First of all, why does this work? Yes, this model was preloaded and prepared for a user, in this case me, to take the session. So let me actually I'll scroll a bit closer here and see what happens if I actually move past a certain point. Yeah, moving in the plant, that's actually the easy task. What happens if I jump straight across the whole plant, just pick some object in the far back and make a fit? So within seconds, it will be loading all additional information so that the time loss jumping between far away points is just a few seconds, if at all. This is also thanks to the technology that UPV uses, that far away objects are not displayed in full detail until we actually inch closer to them to have a closer look. What other features can you actually use with browser-based viewing? Well, many of you probably already have used deep linking. So if you have a local installation of the UPV and want to use UPV API links that you copy from a model that you're using locally and make it available to someone who's, for example, using browser-based viewing, and that's no issue at all. For this, we have a small tool called Web Launcher that needs to be executed once, where machines that do not host any type of UPV application can be registered, and those UPV API links will be redirected straight to the browser-based viewing. Additionally, you can also use direct HTTPS links. I've prepared 2 of them here. The direct link. So I click on the link and I jump straight into the model and get my D240 highlighted here. Let's do the same thing with a pump, the P102A. When I go back to my model, I can see that it's been selected. What does this link look like? It's basically a normalized UPV API link. When you go to administration, UI settings, scroll down to links, you can actually see that we're using a very simple command line assembly here. And in case you have some questions for this, how to actually set up the path, we can also provide you with a small tool that will generate the links for you based on old UPV API calls that you might already have to migrate here. It's based on Excel, so it's a very low weight, high impact tool. So access to models can be limited exactly like in the UPV browser. So we have users, user groups, and eventually permissions that can be granted hierarchically by a model, by folder, and definitely by group membership. And that way you can very easily define which users get to see which models. If they don't have a permission to open the model, they will not even see the model appearing in the overview. And when we're talking about the huge demo and the preloading, I can also show you the dashboard when I say open in browser. Since this one has been preloaded only once, we can go over to the dashboard here. Now we see we have 3 used. I'm using 2, and a guest user that's been automatically logged in as public is using the full demo plant model, while 1 is starting, which is the huge demo, and 7 models are preloaded. That way I can keep an overview of the current model usage and also the current state of the server and how actually the utilization degree of the server. So this was a very quick overview of the basic features of the browser-based viewing. The integration options, and now you see while it's starting, it's showing us the yellow logo. There will probably be a lot of questions Also later on from your side, when it comes to implementation, the requirements, what I can tell you, the hardware requirements for the client, they're basically close to none. So you can use thin clients, you can run iOS, Android, Windows, Linux, Mac OS. The only prerequisite is that you should have a browser available that supports HTML5, which is the case with Chrome, Safari, Firefox, Opera, Microsoft Edge, not Internet Explorer, but other than that, all contemporary browsers will support this. If you have additional questions, feel free to contact us under the shown email addresses, or if you have some specific questions or need some type of information or consulting as to what would be necessary to introduce the UPV web services in your company, feel free to let me know. One last question that just popped out is, what if we reach the limit of a render server hardware? Well, this is also not a problem at all. Instead of scaling up, you can scale out and add as many render servers as you want to, and they will have some type of load balancing between each other to make sure that the best performance is always available for the end user. Again, regardless of hard and software used. Thanks a lot for your time. Have a great day, and looking forward to talking to you soon. Bye-bye.